we talk about monotonicity. Let's move on to our next topic, concavity. Concavity describes certain shape of the graph y equal to f of x. So if you see the graph opening like this, you say the concave upwards. If it opens like this, like opening downward, you say it concave downwards. So oftentimes the graph can look complicated. For example, it goes up and down like that. So in this case, you see part of the curve, for example, this part, it concave upwards, and this part, it concave downwards. So we oftentimes need to be more precise and say, oh, on what interval the curve is concave up, or on what interval the curve is concave down. Okay, so in this case, we see that the curve concave downwards on from minus infinity to a, like all the way it goes like this, right? So it doesn't change the direction, so it stays opening downward like that. And after the point A, then you see the curve, the shape of the curve or the trace of the curve changes. It starts opening up like that. Okay, so even if it just partially like that, you can still see it's opening upward. Okay, so you don't have to see the whole thing. As long as you see part of it, this is still concave up. Okay, this is concave up. Similarly, if you only see part of it like this, this is concave down, because you can see it's opening downward. Okay, so here we have the curve concave downward on the interval AB. Okay, then passing the point x equal to b, we see that the curve is opening downward again. You can see the trend. So concave upwards on the interval b to infinity. Okay, so that's what the geometry is like. All right, so in this case, you can see that there are something also important in this. So that is the point A, f of A, and the point B, f of B. Why are they important? They are the points that separates the part of the graph that concaves down from concave up, right? Okay, so they actually have a name. They are called inflection points. Okay, so I will tell you how you could feel inflection points in daily life. I hope this does not really happen, but okay. So imagine you're on car, someone's driving. Okay, you're just a passenger, and this person drives like this. Maybe you're on in the mountain, so the road is not straight. It goes like this. Okay, so you know when the car turns, you can feel the physics, like the force, like and then when they change the direction, then you go like this. So when your body, when the force that's up on you went from this direction and to this direction, there's a moment when you are like upright. So that's this. That's what do you feel? That's the inflection points. Okay, so we have two things important: concave downward and upward in terms of geometry, and we have this this item called inflection points, they're also important. They help us to separate the part that's concave up and the part that's concave down. Okay? And I'm gonna give you the algebra, how you can determine when a curve is concave up and when a curve is concave down. So here, let's say I have y equal to f of x, okay? If f double prime is positive, then the function is concave up on those x values so that f double prime is positive, okay? And here, concave down is true if and only if f double prime is negative, okay? So let me give you an example in a second. But this is just so you know, this is one property that you wanna memorize. Okay, if you see f double prime being negative, that means it's concave down. So if you have the function like this over this interval from b to infinity, you would have f double prime being negative on the entire interval from b to infinity. And here you would have f double prime positive on the entire interval a to b, okay? And similarly, you will see f double prime negative on the interval from minus infinity to a. So when we don't have the graph, we can just use the derivatives to help us determine whether f is concave up and down and on which intervals. Then of course, the inflection point is the points where f double prime equals 0, okay? Because when you go from positive to negative, you have to pass 0. When you go from negative to positive, you have to pass 0. So that's how you can find inflection points. And we're gonna look at an example.